Hi everyone, and welcome to this week's second lesson on histograms. Today we are going to concentrate on actually drawing a histogram. Pop today's date and the title, and then pause the video to have a go at the do now question, which is on your screen. So the do now question says, the histogram shows the ages of all the workers in a London office. Given that 15 workers are in the age range of 40 to 55, so this would be this bar here, work out how many workers in the office in total. Notice this was like our non-standard question from last time, where we haven't got anything labelled on the frequency density axis. So first of all, we need to work out what the frequency densities are. Now we'll only be able to work out for the one that we've got the information for. So we're given that 15 workers are within this age range here. So 15 is the frequency. The class width or the interval width is 15. Remember, the frequency is equal to the area of the bar, the interval width multiplied by the frequency density. So if the frequency is 15 and the interval width is also 15, we can work out the frequency density by working out the frequency divided by the class or interval width. So the frequency density, the height of this bar, will be 1, and we can label this then on the frequency density or the y-axis. So if we know one of these big squares is worth 1 and it's 10 little squares in between, so each of the big squares going up are worth 1. So we can now work out the frequencies, the areas of the remaining bars. So for the first one, we've got a width of 5 multiplied by 2.4 to give us a frequency of 12. A width of 5 multiplied by a frequency density of 5 to give us a frequency of 25. Then for the other three, you should have got 38, 15 and 6. So how many workers in the office in total? If you add all of the frequencies together, hopefully you've got 96. So for today's lesson then, our bronze objective is to be able to recall and use the formula for frequency density from last time. The silver objective is to be able to accurately draw a histogram, and we're also going to further look at interpreting a histogram. So let's recap from last time what the main differences are then between a bar chart and a histogram. Remember, a bar chart has frequency labelled up the y-axis, so the heights of the bars are the frequencies, whereas a histogram, the frequency density is labelled on the y-axis and the frequency is represented by the areas of the bars and not the heights of the bars. You might want to look back at the main differences you jotted down last lesson. So for a bar chart, we use it for discrete or quantitative data. Remember, discrete data is data that only takes certain values. The widths of the bars are usually the same. There are gaps between the categories. Bar chart has frequency on the y-axis. The frequency is the height of the bar. For a histogram, it's used for continuous data. The widths of the bars are often different. There are no gaps between the categories. I wonder if on the last video you noticed I said there are no bars between the categories. I meant no gaps between the categories. Histograms have frequency density labelled on the y-axis, and the frequency is the area of the bar. So for today's lesson then, we are going to look at drawing a histogram, so it may be useful for you to have your exercise book ready. Let's have a look at this question together. A survey of the heights of 100 Year 10 students were conducted with the results in the following table. Draw a histogram for the data. So continuous data, we have the data grouped, we've got heights, and we've got the frequencies. So first of all, we need to work out what the frequency density is for each class or interval width to be able to plot these up the side on our histogram. So remember the important formula from last time, that frequency density is equal to frequency divided by class or interval width. So the first stage of our answer would be that we need to add in a column for frequency density into our table. So frequency density is the frequency divided by the class width. So 20 divided by the width of 20 would give us the first frequency density of 1. 25 divided by the width of 20 would give us a frequency density of 1.25. 25 divided by a class width of 10 would give us 2.5. 20 divided by a class width or interval width of 10 would give us a frequency density of 2. And 10 divided by a class or interval width of 40 would give us a frequency density of 0.25. So there's my table with the frequency density column added in. Now look, what would this look like as a histogram? So the heights are as a continuous scale along the bottom. We need to go from 100 to 200, and we've gone up in 20s along the bottom. Remember, the class width represents the width along the bottom of each bar, but it's not the frequency, which is the height of the bar. It is the frequency density labelled on the y-axis. So you can see for a bar with width 100 to 120, we have a frequency density, a height of 1. So that the area represents the frequency. 20 multiplied by 1 gives us back the frequency. So for 120 to 140, this is the width of the second bar, and the frequency density will be 1.25, and so on. Have a go at this question. You can pause the video while you do so, make a copy of the table, fill in the frequency density column, and then you can use the squares in your exercise book to make a copy of the axes that you have here to accommodate the data. So the first thing you should have done was work out the frequency density. Remember, this is the frequency divided by the width of the group. So for the first one, you should have done 3 divided by 2 and got a frequency density of 1.5. For the second one, you should have 6 divided by a width of 3 to get a frequency density of 2. For the third one, you should have done 10 divided by the class width from 5 to 10, which is 5. So 10 divided by 5 to give a frequency density of 2. Then you should have done the frequency, that should have been a 25, divided by a width of 10. So this one should actually be 2.5, so sorry about this. And then for the last one, we should have done 10 divided by 20 to give us 0.5 here. So this one is incorrect. I will change that on the main PowerPoint. So now then, when we do our bars for the first one, 0 to 2 has a height of 1.5. 2 to 5 has a height of 2. 5 to 10 also has a height of 2. Now this is where we've made the mistake. So this should have a height of 2.5 now. So this should have gone up here, and I will change this, as I said, on the main PowerPoint. And the last one, 20 to 40, has a height of 0.5. If you print out the worksheet that is in the shared folder for today's lesson, you will have this question printed out here for you to have a go at, along with the exercise that's on the next two slides ahead. Pause the video while you have a go at this question. So to work this out, we need to work out the frequency densities to start with. So for the first one, you should have 4 divided by 10 to give you a frequency density of 0.4. For the second one, 8 shared by 20, also to give a frequency density of 0.4. 15 shared by 30 to get a frequency density of 0.5. and 3 shared by 30 to give a frequency density of 0.1. So the width of the bar should have gone from 30 to 40. So 30 to 40 and have a height of 0.4. Think about a suitable scale up the side first. So if we were using this one here, and generally in an exam they tend to give you the axes already drawn. Like in this question, you need to work out a suitable scale up the side, and that would be 0.1 for each 5 small squares. So a bar of 30 to 40 should have a height of 0.4. A bar from 40 to 60 should also have a height of 0.4. A bar from 60 to 90 should have a height of 0.5. And a bar from 90 to 120 should have a height of 0.1. A non-standard question then. You'll remember from the last lesson, a non-standard question we looked at was when we had some of the frequency information filled in, we had some to complete, and we also had a histogram, but we had no scale, no frequency densities labelled up the side. So the first thing we need to do is work out what the frequency density is for some of these, so that then we can use it to fill in the rest of the table. So frequency density is the frequency divided by the class width. So using one of these we have the information for. Let's use the first one. So we know the frequency is 15 divided by the interval width of 5 means that the height of this first bar must be 3. Now if I look here, if I go across, this is 1, 2, 3, 4, 5, 6 of the bigger squares in total. So 2 of these bigger squares must be a frequency density of 1, and 2 more up must be a frequency density of 2. So we can see this height of this bar here is 2.5. So to fill in the third one then, we've got a width of 10 multiplied by 2.5 to give us a frequency of 25. And for the fourth bar, we have got a width of 20 multiplied by a height of 1 to give us a frequency of 20. You've then got to fill in the final bar for 40 to 60. So work out the frequency density. So this would be 10 divided by 20. So you should now have a bar from 40 to 60, which goes up to 0.5. You can draw this then in. On your worksheet, if you've printed it out, you will now have these questions here if you would like further questions to draw the histograms for. The first one says draw histograms with equal class intervals for these distributions. So it looks as though the information is missing here, but remember these should be equal, so you'll be able to work out what this value is here. Choose 1 or 2 maybe to do. Feel free to do all 4 if you want to. The answers are on the next slide, so pause the video while you have a go. So here are the answers. It doesn't actually show you the frequency, the histogram, but it does give you the frequency densities you should have used. I've also chosen question 4 for you to have a look at, so pause the video while you have a go. A few hints. It asks you to explain how you work out the number of trains that were included in the survey. So you've got to work out the areas of each of the bars to be able to work out the frequencies and then total them together. How many trains were delayed for longer than 15 minutes? So you would have to work out the area of half of this bar and add it to the areas above. Once you've done that, the answers are on the next slide. So now there is a final Hegarty clip assigned to you for this week, and that is clip 446. So now there are only 2 videos because the video from last lesson was quite long, and by pausing this video and drawing some histograms out, that would have taken you a while as well. So use up your 3rd hour for this and also to complete the Hegarty tasks. As a final question, have a look at this. Is this correct? Pause the video while you study the histogram to see what they've done. So the question, Mr. Smith has drawn a histogram to represent his class's examination scores. Can you explain what Mr. Smith has done wrong? Then can you draw a correct histogram for him? So remember, so he's plotted frequency density up the side. Okay, so that isn't his mistake. Remember, frequency density is the frequency divided by the class width. So for this first one, we would do 3 divided by 30. I can see what he's done. That wouldn't give us 10. He's done the class width divided by the frequency. He's done 30 divided by 10. So he's done his division the wrong way round. So his frequency densities are incorrect.